So just in case we are not able to retrieve the rocket, got a little please return note with my email and phone number in there. We're going to do payload integration. So this is the Ghost Chaser Estes, basically shake the box kit. We're going to launch on a B engine. This is its maiden voyage. But the experiment is looking at what is the effect of the gravity forces on seedlings, and also looking at the symbiotic relationship between the rhizobium and the legume seedling itself. So some of these have been inoculated, some of them haven't. So RFC, that's red flight control. So that's a red clover there's a damp piece of filter paper in here, and the bag is sealed. So these are seedlings that are about 4 days old. Okay, so this one has not been inoculated. Slide that in there to the payload bay. Red ground control, so that's going to stay here. White ground control, that's going to stay here. White flight experimental. So this is a white clover that's been inoculated. Red ground experimental, so that's red that's been inoculated but it's not going to fly. And then red flight experimental. So that's the red clover that has been inoculated. And push everything up in there and mount the payload and nose cone onto the rocket. It has a parachute return. Estimating about an 800-foot flight today. Very light breezes. And I'm going to collect all the pre-launch weather data right now.
Mm-hmm. Can we connect it?
You are
Clear.
Safety's out.
Okay. Right, they're on.
Okay. Range is clear. Let's just let that wind come down. Oh, pull the. I guess you better pull the wind vane.
Yeah.
Okay, it's 4th of July 2020, maiden voyage. We are testing the effects of launch acceleration on rhizobia and legume seedlings. There are 3 different sets of seeds. One white clover that is inoculated, one red clover that is inoculated, and a red clover that is not inoculated. We're just waiting for the winds to come down a little bit. They're only about 1 to 2 meters per second in terms of their gusts, but obviously we would like as still as possible. Running a B64 on this, which means it's the impulse is for 6 seconds, 4-second delay. So we should achieve apogee, maximum altitude, in about 10 seconds. My launch assistant Matthew is going to be charting the angle of ascent so that we can calculate the altitude. But it's a beautiful day. It's 30 degrees Celsius, 1,015 millibar pressure, so nice stable air, and humidity is a little high. It's 45-46%. As I said, the winds are out of the north-northeast at about 2 meters per second, 1 to 2 meters per second for gusts. So I'm just going to let this gust calm down, and I think we'll probably be ready to go. Range is clear. We've launched many a rocket out here. We've only lost 1 or 2. The tree line is a little tricky, but if we get a nice straight flight and descent, we're pretty certain we'll capture. Just in case there's a little note, please return inside the payload, so that hopefully we'll be able to retrieve it. Matthew, we look good to go?
I think so.
Okay. Armed. Range. Clear. Okay. Launching in 3, 2, 1. Ignition. Ignition. Go, look at that. Nice flight. Okay, we couldn't have asked for a better flight on that. That was by the books. So it came pretty much where we were hoping. Okay, we'll step it out on our way back, but everything's intact. Chute deployed on schedule. Payload's still here. So we'll take it back to the lab and do our post-flight analysis. Beautiful launch. We landed about 40 meters downwind of our launch site. So that was a nice clean flight, right within the bounds of our field here. We'll calculate the perigee when we get back to the lab, as well as take out our flight specimens and see if we notice anything visual. We also did a GoPro high-speed here, high-speed photography, so we'll integrate that into the final video and see if we can get a slow-mo of the launch, because it took off pretty quickly with that beam engine. All right.